is 4. Right? And then the question is ask you what's the loss of the energy, kinetic energy. We need to calculate the initial kinetic energy and the final kinetic energy. The initial is 1/2 times 3 times 5 squared plus 1/2 times 2 times -2 squared. And in the end is 1/2 times 3 times 1 squared plus 1/2 times 2 times 4 squared. And here is times 25 plus 4. Here will be plus 16. So if you use this value minus this value, like kinetic, final, kinetic, initial, equal to -24. But the question is asking how much kinetic energy does the system lose during the collision. So the answer will be 24. Okay. Then number 9. This one is okay. So again, a combination of potential energy and momentum. 3 kilogram mass with initial speed of 3 meters per second and collides with 1 kilogram mass which was at rest. And then the masses stick together and slice up to this circular track. Okay. And then they went to a maximum height here. What we need to do is we need to know the initial speed. Actually, it's the final speed after the collision, right? So the initially 3 kilogram, 3 meters per second. This is 0, the initial. And then they stick to each other. And then 3 plus 1 times the velocity, right? So will be 9/4. That's 9, that's 4 meters per second. And then from here to here, here is only kinetic energy. And here is only the potential, right? The kinetic energy is 1/2 the mass. You need to consider them together because they stick to each other. And then the velocity square equal to mgh. M is also 3 plus 1, 9.8. g, and h, we don't know, we need to calculate this. So if you calculate mass h is equal to here is 81 over 16, right? 94 times 1/2 divided by 9.8. And then if you calculate it, it's 0.258 meters. So the answer is D, 0.26.
Okay.
Number 10, 2 kilogram block hanging on a 1.5 meter string. A 10-gram bullet moving with a horizontal velocity 900 meters per second strikes, passing through, and then the final speed is 300 meters per second. And then after this bullet passes through, this thing will go up. But the first thing we need to calculate is what the velocity after the collision. Okay. The initial, the bullet is 10 gram, again is 0.01 kilogram times 900 meters per second. That's the initial momentum, right? And then after the collision, it turned to 300. But the ball got a velocity, right? It will be 2 kilogram times the final velocity. But that's a conservation. And then if you calculate, the velocity will be 3 meters per second. And that will turn to this question. A spin. This ball at the bottom has a velocity 3 meters per second, and how high it can go to. What's the h here? So it's the same thing as the previous question. Here is the kinetic energy is equal to the potential energy here, right? Will be 1/2. It's 2 kilogram, 3 meters per second is equal to mgh. M is 2 kilogram, 9.8 times h. So if you calculate h is 0.46 meter, which is 46 centimeters. This one is C.